Hi class! Welcome to the LEGO Bricks in Space program. It's time to get out your student worksheet. Working alongside the crew on board the International Space Station, you will find all the answers to the questions on your worksheet. Teachers, when you see the pause prompt on the screen, please pause the video to give students time to record their answers. Hold on to your seats as we launch into space.
Sensors in many space science operations such as radar topography and remote sensing. Even our robotic roommate, Robonaut 2, uses sensors to enhance its functions. I have the same model up here in microgravity, and it also uses motion sensors. I built the same program up here to control the model, so let's take a look at it. For this spinner model, the program initially activates the motor and plays a sound. The motor is programmed to continue to spin until the motor sensor detects a change in motion. In this case, the change in motion is the upward motion of the LEGO brick spinner handle after the release of the top. Then the program detects the motor. You may recognize this string from the activities you did in your classroom. In your classroom, you experimented with the spinning top. Let's experiment with one now in microgravity. So first, I'm going to release the spinner top on a flat horizontal surface. How long do you think it will spin? What do you think will happen? Will it be different than in your classroom? If so, how? Watch the spinner's gears and the spinner top as I release it from the handle. Did it work the same as in your classroom? How is it different? How could you describe the actions of the spinner top? Make sure you write your observations about the last test on the flat horizontal surface, because now we're going to do a test on a flat vertical surface. I'm going to hold the spinner model vertically against the flat surface. Now, do you think it will react differently than the horizontal surface? Okay, so again, now watch the spinner's gears and the spinner top as I release it from the handle. What observations can we make about how the spinner top performed on a flat vertical surface in microgravity? How is it different from a flat horizontal surface test? Did it work the same as in your classroom? It was much different up here in microgravity. How would you describe the actions of the spinner top? How could you use Newton's laws to explain the motion of the spinner top? Record your observations in your student worksheet, and feel free to make your own observations. So you saw what it looked like from a flat horizontal surface and a flat vertical surface. Now I'm going to try releasing the spinner top again, but this time we're not going to press it up against anything. I will do this free floating. What do you think will happen this time? What direction do you think the spinner top will go? Watch the gears of the spinner top as I release it from the handle. Okay, ready? It sort of floats out. No cheating. I have to hold it a little bit till I'm ready. I don't want to get hit by it. I don't do anything sudden. Oops. This is tricky. What observations can you make about the spinner top floating in microgravity? How would you describe the actions of the spinner top? How could you use Newton's laws to explain the motion of the spinner top? Did the spinner top perform like you expected? Or like a spacecraft? So I'd like to ask you a few questions about our experiment. Question 1. How long did the spinner spin during the flat horizontal surface test? And how about during the flat vertical surface test? Question 2. Did the Lego brick spinner work in microgravity same as it would in the classroom? If not, how is it different? Try to explain your answer. Question 3. In your classroom, can you write a program that uses a different sensor with the Lego brick spinner model? Describe that program. Question 4. What other design could you create that utilizes the motion sensor? What about other designs that use a tilt sensor? And thanks for stopping by the ISS On-Orbit Classroom. We've had a lot of fun today, and I hope you enjoyed being in microgravity with us.